Hey there, guys. Today what we're going to look at in the Caddy Daddy garage are heater blower motor resistors. This is what gives you your various speeds on your fan for your heater and air conditioning, defrost. Put resistance in line with the motor. So if you notice that your blower only blows air on high or low doesn't work, you're missing speeds, this is a part to check out. And a lot of cars, it's fairly easy to get to. Some cars it's more difficult. It'll be mounted in one of the ventilating plenums under the dash. Just a couple of screws hold it and got a plug that plugs in. So if you've got some intermittent symptoms with your or speeds missing on your blower motor, this is a lot easier thing to check than to check the switch. And while you're down there, you can also check for the power feed from the switch. Let's get to looking at two methods of testing this. One's going to be kind of a quick and dirty way if you don't have a lot of test equipment. The other is going to be more scientific, where we actually calculate the values of the resistors and compare them to what's specified in the service manual. So let's get started. Okay, guys, let's go over a test setup that we got going today. First thing here is a adjustable power supply. You can use a car battery if that's what you got. We have our load resistor, which, if you've noticed, it's been upgraded a little bit since the last time we used it. Put a light on it so it's a lot easier for you guys to see what's going on, and painted the board, made it look nice. We have a multimeter set up to measure current, and we have a voltmeter to measure the voltage drop across the resistor. But we're going to start out just doing this a quick and dirty way to see if the connections here are still good and that we have resistance throughout the device. So we'll get the voltage turned up here. As you can see, we have current flowing, and we have, you can see on the indicator light, about 4.8 amps. So on this unit, I've drawn out the schematic here, and this point here I've labeled A is the first stage of resistance. And as you can see, we have current flow, we have light indicating, and we have less current than we had when we have a short circuit right here. Now we'll go to the next stage. So that first stage was half an ohm. Now we go to a second stage, which adds another half ohm, which would be to this point. We'll see our currents drop more. The lamp is just a little bit dimmer. Then we'll add in 0.2 ohms, which will be this last resistor to this here, even less current. And at this point and this point are tied together. They're common, so we'll just double check that we have the same result here. Now what we can do also is, if you have multiple multimeters or a dedicated voltmeter that you can do make simultaneous measurements, what we can actually look at is we can calculate to verify that the resistances that we have, I mean, we know that now that the device has a complete circuit. We know that it's conducting, and we know that if we've lost a speed on our blower, it's not going to be this part here. But let's go ahead and we'll make one final check here that lets us actually calculate the resistance and see if they're in the ballpark of what's expected from the service manual. So we'll take and make our first connection. Push the button on our voltmeter. And to make this easier, since I got a variable power supply, I'm going to turn this until I get an even 2.5 volts and an even pretty much 4 amps. So we have 2.5 volts dropped across that resistor with 4 amps flowing through it. We can get on our calculator, 2.5 volts at 4 amps divide, we get 0.625 ohms. And it calls for 0.5. So that's in the ballpark. Electronics, 10%, 20% tolerances are standard. So that looks good. And we can go through and repeat that process on all of them. This one here is looking like it's about 2.5 0.45 volts. We can put that in 2.45, enter, and right still around 4.007 amps, 0.611 ohms, and that one should be 0.5. So that one looks good too. Now we'll check the final one. And where are we at on our meter here? We'll turn the voltage up there. Just playing with the voltage just to give some round numbers, make it easier for you guys to see on the meter. This is easy enough to see, but that's a little bit small. We're going to increase the voltage a little bit. We got 2 volts at 4.7 amps. So 2, enter, 4.7, divide, 0.4. That one's supposed to be 0.2 ohms. Close enough. I mean, for the job that this is doing, this device is in good condition, serviceable. So if this isn't your problem, if you're having blower motor speed control issues, so you'll have to look elsewhere, likely to the switch. And we'll do a video on checking the switches in the climate control module or unit sometime too. I hope that helps you guys out and helps you to be able to locate your troubles and to be able to order the exact part that you need to repair your car. Click on the link in the description below and it'll take you right to the part that you'll need for your car to get everything up and running perfect.
Vine Village is a great organization that gives back to the community. Check it out. You'll see so as well. Thanks for watching.
Hi, my name is Sanan Kirsten. We're here at the 2018 Vine Village Celebration, our major fundraiser here that helps fund programs that we run for people with developmental disabilities here in the greater Napa community. Vine Village was founded by my family and another family, each who had children with disabilities, in 1972. We depend on donations from all sorts of foundations and individuals and businesses throughout our community to help fund these programs, and this is our biggest fundraiser of the year.
You can donate by clicking the link in the video description.